Hello, this is Dr. Speranza and welcome to my calculus class. And for today we're going to be working on the derivative rules and how to use the derivative rules correctly. So we're going to be seeing the power rule, we're going to see the quotient rule and the trig functions and how to find its derivative in today's workshop. And today is going to be a little bit special because you're going to be sitting in my classroom with my student here in Barstow Community College. So stick around and let's learn the derivative rules. And if we have the derivative of sine, cosine, and tangent, we have the derivative of its inverses. And those inverses will be cotangent, secant, and cosecant. So the derivative of cotangent u is negative cosecant squared u du. Derivative of secant u is secant u tan u du dx. Notice that I have two different forms of du and du dx. They are just the same. You're finding the derivative of that function u. And that function u can be of any form. It could be a 2x, it could be an e to the 2x, it could be an x, or it can be an x squared plus 7, depending on the u function. So always remember that you will see a u in your trig function. In memorizing derivative rules is writing the rules by hand, because the more that you use your handwriting in working with derivatives, the more that you will learn it, even though I'm going to give you this. So this is our formula sheet. So before you can use your formula sheet, make sure to write down your formula in a piece of paper so that you will remember or help you remember them. All right. And the reason why it's formula, it's because it is going to help us find the derivative by finding the u and the du. That's all we need to do. Okay, so this is our formula, and we're going to start with this. Okay, the f of x is negative 2 sine x. And which derivative formula are we going to use to find the derivative of this function? Obviously, the ddx of sine x. So if we're going to rewrite this, f prime of x is equal to, is this a constant? So we can set it aside and focus on the ddx of sine x. All right, now let's focus our attention to ddx of sine x. What is the derivative of sine x? Cosine u du dx. So if we're going to find the ddx of this, we need to produce this, right? So let's write it down. Cosine u du. There. And again, we're writing it down so that we will have a pattern to follow. And all we need to do is to find what u is and what du is. So let's do that. What is u in our cosine u? X. And what is the derivative of x? 1. And now we're done. All we need to do is to put them all together. Cosine u du. Are we forgetting something? Yes. And this is now your f prime of x. Can we make it pretty? Alright, so let's make it prettier by multiplying this and this. So our f prime of x is equal to negative 2 cosine x. Easy. So again, always do this step. Write down what you're trying to produce so that you won't get lost in the formula. Because the more that you're understanding the formula, the easier this will get. And all derivative rules that are too complex is easier to remember if you are following this technique. So we're learning this technique because this is the technique that worked for me, and I'm sure it will also work for you. Secant e to the 5x. So we're finding f prime of x. And what is f prime of x? Derivative of this. So let's write it down. d dx of secant e to the 5x. So which formula are you going to be focusing on in this formula sheet? The derivative of secant u. And the derivative of secant u is this. It's a long formula. And again, don't get too intimidated with the formula, because the goal in finding the derivative of a function is not to make the function smaller. It is to make sure that you're writing it according to the formula. Okay? Sometimes the derivative of function can become smaller. Sometimes it can be a little bit longer. And this is one of those cases. So, since we're trying to find the derivative of secant e to the 5x, let's write down what the format of our answer should look like. Secant u times tangent u times du. Those are the things that we're going to produce. What's the easiest to produce in that formula? U. And what is u? E to the 5x. Yes. Now, what is the derivative of e to the 5x? Do you still remember how to take the derivative of e to the 5x? E to the u times du, right? What is the u of your e to the u this time? 5x. And what is du? And now we have e to the times 5. Can we make it prettier? Yes. What you just did is, this is the idea of a chain rule. The chain rule is taking an f of g of x, a function inside a function. And what is the function inside the function? Your main function is the secant. Your second function is e to the 5x. This is the chain rule that you're working on. Alright, so now that we have our u and du, we just need to write it down to our answer. Secant, what's u? E to the 5x, tangent, e to the 5x, times 5e to the 5x. 5e to the 5x. And we're finished. This is f prime of x. All we need to do is to make it prettier. Take a shot at it. In standard form, the standard form is the du will always be at the front. That is your derivative. Let's see. Yes, yes, yes. Yes, yes, yes. And that's how you use your formula. Let's have more? Of course. You're not going to learn this by just working on one problem. Do you need to modify your f of x first before you can use your formula? Yes. Again, it's always algebra first before calculus. So do your algebra first before you can use your calculus skill. Give me a shot. What's your modified version here? Yes. And now you have a constant that you can ignore for a while and focus on the f of x. And your f of x is there. And now you're going to differentiate using the formula. The formula of tan u is secant squared u du dx. What's the du? 5. And just put them together and you'll have your derivative. 5. Am I forgetting something? The constant. Don't forget the constant. I know that we're setting it aside, but make sure you don't forget. because sometimes I forget. So my f prime of x, to make it prettier, is 2 all over 7. No. What's 5 times 2 all over 7? What's 5 times 2 over 7? If you don't know your fraction, please watch Aaron Sanchez and I's video on how to multiply fractions. 2 over 7 all over 5. Aaron Sanchez will teach you how to multiply 2 over 7 and 5, which is
10 over 7.
derivative of 2 tangent 5x all over 7 is 10 over 7 times secant squared 5x. But if you're taking the AP Calculus test and it's in the multiple choice, you need to be aware that it could be of this form or this form. So make sure that you know your algebra so that in the multiple choice, you know what to look for. Next rule. So we've learned the e to the u rule. We've learned the trig function rule. We've learned how to modify the function so we can use the power rule. Now the last two rules for today. F times g and f over g. These are the quotient rule and the product rule, which means you are multiplying two functions or dividing two functions, and when that happens, this is how you differentiate it. Too much? Don't need to copy it yet because it's in the formula. However, we're going to be using them to make sure that you are understanding them just like what we, or how we use the trig function rule. Alright, let's have the first example. To be able to use the product rule, you need to identify your f and your g in the function. Okay, that's your first step. In this function, can you identify the function f and the function g in your h of x? Let's start with one. First one, what is f here?
E to the 7x.
Good job. That is your f. And obviously, what is your g?
Cosine 2x.
Always write down and modify your function before you can use the formula. To find h prime of x, we're going to produce f prime g plus f times g prime, which means we need 1, 2, 3, 4 terms. Now, in this derivative, we already know what f and g is, right? This is f and g. We just need to figure out your f prime and g prime. So let's answer it. Let's start with f prime. And how do we find f prime? The derivative of e to the 7x. And then you need to use your formula. What is the derivative of e to the u?
E to the u times du.
Yes, so write it down. E to the u times du. That's what you're going to produce. What is u?
7x.
And what is du?
7.
7. So f prime of x is equal to e to the 7x times 7. Can you make it pretty?
7.
Yes. Okay, this is your f prime. So we're done with the f prime. We just need to find the g prime because we need that in the formula. G prime is the ddx of cosine 2x. And what is the formula in finding the derivative of cosine 2x? Tell me. Negative sine u times. Alright, always write the formula so that you will know where you're heading. Your u is 2x, your du is 2. And now we have the g prime, right? And what is the g prime? Negative sine 2x times 2, or negative 2 sine 2x. That is your g prime. And again, now that you have all the ingredients you need, just put them all together and you have your derivative. Is it going to be a long derivative? Yes. Because the formula is wrong. Because the formula is long. So since the formula is long, your answer will be long. Can you please write down your answer? Minus it, but we know it's minus, right? Minus, minus, because of that. And sine 2x, sine 2x. Okay? Now, recap of this long method. Every time you're finding the derivative of h of x or any function, make sure that you are identifying your f and your g so you can use your product rule, okay? And then just use the derivative, and again, it's all about symbols. F prime means the derivative of f, g is the original, f is the original, and g prime is the derivative of g, okay? You need to have two functions, f and g. F and g will be obvious, right? This is f and this is g. Now to find the derivative of h of x, you need this, this, and this in that order. So you have your f, you have your g. Let's find f prime and g prime. Okay, starting my f prime, which is d dx of 5x cubed. F prime is going to be 15x squared, right? And then my g prime. My g prime is the d dx of e to the 2x. And we know that the g prime of e to the u is e to the u times du. I need to have my u and I need to have my du. My u is 2x, my du is 2. Put them together, g prime is 2e to the 2x. I have my g prime, I have my f prime, I have my f and my g. All I need to do is to write it according to the formula. H prime of x is equal to f prime of x times g of x minus f of x, 5x cubed, times g prime of x, 2e to the 2x, 2e to the 2x, all over gx squared. And what is gx squared? Just square g, e to the 2x squared. And you're finished. This is your derivative function. Can we make it prettier? Of course. Combine this, and it will be a less cluttered answer. But if you are just starting, leave it like so. Why? Because what if the question is find h prime of 1? How are you going to find h prime of 1? Plug in 1 to every single x in your formula and you'll get your answer. That's why sometimes I don't ask my student to simplify it to the simplest form, because most of the time we're looking for an h prime of a number. And when that happens, it will be 15e minus, you got the drill, right? Am I correct? Are we correct? E to the 2x, e to the 2x, 15x squared, minus 5x cubed, 2e to the 2x, e to the 2x. Okay? Right. Recap. The product and the quotient rule can be used if you can identify your functions, f and g. So this will be your formula. And again, at the beginning of learning all these formula, it's awkward, it's strange, and it's a little bit challenging. But if you do this over and over and over and over again, you will realize that it's really just remembering your formula. If you know your formula, you know your derivatives. And to be able to memorize it, you don't memorize it by reading it over and over again. You memorize it by using it over and over and over and over and over again. Let's test your skill. Boom. Answer all three of them. And if you need to know more about the derivative rules and to practice on those rules that we are learning right now, please click on this I button right here to lead you to the examples and exercises that I've been working on these derivative rules. What rule did you use to answer problem number 1? I'm not asking you for your answer, but tell me the rule that you use for number 1. The quotient rule? Because this. Think of algebra first before you use calculus. If you use your quotient rule, will you still get the same answer as modifying it to 3x cubed? Of course, yes. But it would take a while, and it's prone to errors because you have so many functions in your fraction. But if you did this, it's just f prime of x is equal to, boom. This is like taking the derivative of 2 pi e to the negative 3. What is the derivative of this function? 0. You need to develop the I. And again, developing the I with calculus takes practice and mastery. So it's okay if you use the quotient rule because everybody goes through that stage. But the more you see a fraction or function, the more that it gets easier. Number 2. How are you going to attack number 2? What rule did you use for number 2? Did you use product rule? And I see why. Not that it's 0, but what do we know about e to the 6? It's what? A constant. And what do we do with the constant when we are finding the derivative of a constant in a function? We set it aside and ignore it and focus on your f of x. And what is the f of x? There. So it will save you the trouble of doing those crazy steps, long function, and just focus on f prime of x is equal to e to the 6 times d dx of cotangent u cotangent 8x. And what is the derivative of cotangent u? And that is the only thing that you're going to focus on so that it's less stressful and it's quicker. Are we finished with this answer? Don't forget. When to use the quotient and the product rule and when not to use it. Why? Because the product and the quotient rule, as useful as it is, it's cumbersome. It's too tedious to work on. So if you can always modify the function, it will make calculus a lot easier to process. What about the third one? All of them are numbers. This is 2. This is 3.14 all over 2.7. It's a constant disguised as a math symbol. So know your math constants so that you won't end up with the quotient rule when it's not necessary. Although you will still get 0 in your answer, but it would take you probably 5 minutes to realize that it's a constant. But if you can realize it right away, you know that this is 9x squared, you know that this is negative 8e6 cosecant squared 8x, and you know that this is equal to 0. How about that? Okay. Product. Quotient. What is 3? Power? It's like, since you're not saying it's a product rule, maybe it's a power rule. What? Is it what?
Is it the trigonometric one?
Yes, it is the trigonometric function, but which one? Yeah, derivative of sine. This is sine, and this is u. So it's just the ddx of
I
sine.
really overthought that one.
Because you thought, are we going to distribute the sine? So it'll be sine 3x and sine 5? But it feels wrong. Yes, it feels wrong because it is wrong. Know how to identify the function so that you know the rule that you're going to be using. So this one, okay. Now that I've given you all your clues, make sure your calculus is right. So this one is already the derivative, but if I want to be adventurous, I can factor out the e cosine x because it's common to the first term and the second term. So now I'm left with negative x sine x. And putting this together, so it's cotangent 3x secant squared 5x plus 3 tan 5x cosecant squared 3x all over cotangent squared 3x. I mean, that's another version of it, but this is already unacceptable. 3 cosine boom. And again, this is Dr. Esperanza, and thank you for spending your time with me learning calculus. And if you happen to like this video, please like, share, and subscribe to my channel. And if you happen to know anyone who is struggling in mathematics, please share this and tell them that they can watch my videos from algebra all the way to college level calculus in my YouTube channel. Thank you, and see you again next time. Bye! Powerful for each term, right? Now, do you see the two functions I'm talking about here? The first function is